above opening class. In the previous class, we have seen about zero-dimensional object which is point, one-dimensional object which is line, the two-dimensional object which is plane. Okay, so these three objects were never existed. We are using these objects only to study what is the 3D objects looks like. Right? So for the 3D objects, we are going to see position of solids. So we will see one of the importance of the position of solids.
So, good morning everyone. Today we'll be seeing about projection of solids. So basically solids are 3D objects which has length, breadth, width or thickness. So we'll be having a length, breadth, then we'll be having a width. In some cases we'll be having either width or thickness. So when it comes to projection of solids, basically we'll be handling with four types. First one is pentagon. Second one, the second one is hexagon. In pentagon and hexagon, we'll be discussing about both prism as well as pyramid. And thirdly, we'll be seeing cone, and lastly, we'll be seeing cylinder. So here, like in cone and cylinder, we don't talk about pyramid or prism because when it comes to cone, pyramid, the circular base is considered as cone, and a prism with circular base is considered as cylinder. So here, the given question is that a hexagonal pyramid side of base 25 mm, axis 50 mm long, lies with one of its triangular face on HP and its axis parallel to VP, draw its projection. So here the shape that we are discussing is hexagonal pyramid. So when it comes to hexagon, we will be discussing about two shapes. So two types we'll be discussing. The first one is this one, and the second one will be this particular thing. So in this case, the question that they have asked is lies with one of its triangular face on it. So when we are taking the second type, if we are actually tilting it or inclining it at some angle, we won't be getting a triangular face of what we have got here. So for that, what we'll be sticking on with this, that's the first type. So when we are actually taking the first type, what happens here is that we'll be getting this triangular face. So in the question it is given that it has a side of base 25 mm. So using the stencil we are drawing a hexagon which has a side of 25 mm. And then furtherly we are drawing the diagonals. So then what we are doing is that we are dragging the diagonals upward of 50 mm as given in the question. So once after taking, so in the question it is given as hexagonal pyramid, which means that the axis which we are actually taking there must be at one point in the above HP. So what we will be doing is that we will be stretching these lines and we will be joining it together at that point. And by coming to the naming of this hexagon, so when it is of prism, we will be naming we'll be giving two names. One is A, B, C, D, E, and F. And the other one will be 1, 2, 3, 4, and 5. Because when it is of prism, prism is basically a shape with two faces which are parallel to each other, connected with to the other face through lines. So in that case, we will be giving two names as A and 1, B and 2, C and 2, then 3 and 4 and D, E and 5, and F and 6. But here, since we are discussing about pyramid, we will be giving only A, B, C, D as names. So for each corner, we will be naming as A, B, C, D, E, and F. And the center one where all the diagonals meet will be named as O. So when we are actually stretching it, what happens is that we will be naming it with respect to O dash. So here we have named it as A dash and B dash. Particularly if you note here, we can see that this A dash is given in bracket. It is given in bracket because it is given in bracket because A cannot be seen from the front view. So when we see it from the front view, all will be seen as that B, C, and D. That's why we have given B dash, C dash, and D dash on the outer side, and whereas A dash, F dash, and D dash are given the brackets since it is not visible from the front view. So this is how we name it. So as per the question, we have drawn a hexagon with 25 mm base, and we have actually stretched the axis line to 50 mm. And now for the second half of the question, where we are, where it is given that one of its rectangular face lies on HP. So the triangular face is actually been lying on HP. So what we actually do is that we measure the angle of this particular point, and we will be measuring this distance, that is B dash to O dash. Measuring that, and we'll be putting it on the HP where comes the triangular face, and then we'll be keeping a protractor over here and we'll be measuring the angle. So basically like that is B dash, E dash line to B dash, A dash line will be the same length of here. So we'll be drawing it, and then for this particular length, we'll be measuring the length of B dash, E dash, and C dash, F dash, and we'll be putting it here. And as we have done earlier, we'll just connect the lines and we'll have get our diagram. Then what we'll do is that we'll bring down the lines from these points in order to get this action answer. And from here we'll be taking our horizontal lines. And then we'll be having the points where it meets. So say for example, we are taking it from here, and at this particular point we have E coming from here, and from here also we have E coming. So we'll be marking that particular point, and we'll be getting 6 points, and from here we'll be getting our O dash point. And what we'll be doing is that we'll be connecting all the dots so that we get our hexagon, and then from here we'll be connecting the points to here. So here we are actually getting the dotted lines because it's not seen from this side, so we'll be drawing the dotted lines and we'll be putting it together by which you get the required answer. Thank you.